Hey, it's Kley. Welcome to another video. Today we've got this amplifier out on the bench and I want to do something fun and useful with it. This is a single-ended hi-fi amplifier. It's basically like a Fender Champ, but it's got two output transformers to send a stereo signal. And I had intended to use it with a stereo setup for listening to music. But, for example, this is my kind of listening place down here, and I've got this IEMA solid state amp that actually does amazingly well. And I've got another one upstairs on my hi-fi receiver. So this has been sitting in my closet up on this shelf of doom where projects go to die for like years now. And I've decided that that's not acceptable. This is a cool amp. It's got cool parts. It's got some nice transformers. It's got these cool Edcore and a classic tone power transformer, a choke. I mean, I got lots of cool stuff here. So we are going to revamp this puppy into a guitar amplifier. So if you're curious about that, why don't you dive in and why don't you stick around and then I'll dive in. Let's get started.
All right, so let's dive in here. Now, before I get into the actual build part, I want to talk through my design goals, what I'm shooting for with this. I've got a couple of ideas that I want to explore. First of all, I want to explore a single-ended 6v6 output section, tube rectifier, and a very simple preamp, because that's kind of inspired by like a Fender Tweed Champ. And Fender Tweed Champs are known for their touch responsiveness, for their dynamic range, for just being really fun to play, for having a really organic, natural distortion and breakup, for riding the wave from clean to distortion with your volume control, being very responsive to that. And I really love those things. But in my experience with a Champ, the shortcoming of that is its limited lack of EQ. It just has no real capability. Even a 5F2A Princeton adds a tone control, but it's still very, very limited with its ability to tweak the EQ. So what I want to do is basically keep the feel and the vibe and the spirit of a Champ, but give it some capability of being a little more flexible with its EQ so that you can dial in maybe a couple of different types of guitars. So this is the schematic that I came up with. I worked through a couple different revisions and maybe made a couple changes. I did make a thread on TDPRI and got some excellent input per usual. Those guys are awesome. But the basic idea here, and the real inspiration of this, is to kind of use a parallel paths idea. So kind of thinking about a Plexi. A Marshall Plexi, you've got the bright channel and the normal channel, and they're like on their own. The normal channel is like excessively dark, and the bright channel is excessively bright. And so when you put them by themselves, they sound harsh in one way or the other. But when you mix them together, they kind of come together to form this glorious union of high and low. So that's what I wanted to do here. I basically have a high signal path, which is going here on the bottom, and then a low signal path on the top. Each signal path is getting two triode gain stages, and then they're joining here just before the output section. So let's talk through it a little bit. We got to start with the power supply, though. I think that's the best place to start. I've just got a simple IEC power plug running into a fuse, into an on-off switch, into a power transformer. Now, my power transformer is maybe a little bit overrated for spec. This is my power transformer. It's a classic tone 40-18021. I think this thing actually is meant for maybe more like a Princeton reverb, but I'm working with it. I think it's going to be fine. And the real way that I made it work is by using a tube rectifier. So I picked a 5Y3 tube rectifier. I specifically chose it because it will have one of the highest levels of voltage drop. So if, for example, compared to like a solid state diode, there's going to be almost no or a very minimal voltage drop or inefficiency through the rectifier stage going from AC to DC. Well, with the 5Y3, of all the different rectifier tubes, this one has a pretty significant voltage drop. I want to say it's somewhere between like 40 and 50 volts, which in my situation is probably actually a good thing. It's going to add a little bit more of a different character to the feel as opposed to solid state. It's going to be a little bit spongier and looser and saggier, especially when you're cranking it up and you're really digging in on those low strings. to try to make those big waveforms amplify. It's going to cause the whole thing to just kind of sag a little bit, which I think is a fun feel to go for with this amp. Next, I went for 32 microfarads at 500 volts. These are the filter caps that I originally had, and I stuck with them on this one. I would say they're more of a moderate to high value, so the filtering here is going to be fairly robust. We go, the first node fills into the output transformer. My output transformer is this EdCore. It's a little 5-watt model intended for 6v6s. After this first gain stage, B plus stage, I run through a choke actually. This is the FBFDR-C choke. With most Champ type amps, you probably wouldn't run a choke, but because this came from a hi-fi build where you want a little bit more of a robust power supply, I've got a choke here. So this thing actually should be very efficient and also filtered quite nicely to be a very quiet amplifier, which I think should be fun. Another 32 microfarad at 500 volt filter cap, and then a dropping resistor 4.7K at 3 watts into a final 32 microfarad cap. One funky little nuance here actually is, I could have done this in a couple of different ways as far as like how I did this second and third B plus stage. It probably would be most ideal to have each tube have its own B plus stage so that they're not synced together. It's actually not great design to have like the 12AX7s linked together, but it's also not the end of the world. But then the interesting thing about this transformer too is that it has a center tap that you can use to supply the screen grids. Now it'd be more common that you would actually use this B plus node here to power the screen grids, but what I chose to do instead is use this to power this second 12AX7 stage. So it's actually going to be a little higher voltage because there's no real dropping resistor here. So I'm actually running quite a higher voltage into these 12AX7, this 12AX7 here, the second gain stage. And then the first one is going to be a little lower voltage after this 4.7K dropping resistor. But overall, I actually was pretty happy with how that turned out. I thought it turned out fine. And it sounds good. And these 12AX7s are pretty robust. They can handle it. So, let's walk through the signal path now after we've kind of walked away through the power supply. The power supply overall is just kind of an interesting setup because, again, you've got like this tube rectifier to be kind of saggy, but then you got little higher capacitance filter caps and a choke and a little dropping resistor. So it's overall like a higher voltage, higher filtering power supply. So it should result in a pretty quiet little amp. So let's go over here to the input. Our input jack, just a single input jack running into the tip. I've got a 1 meg resistor to ground to help set the input impedance. Then I split here into two 33K grid stopping resistors into each of the two grids of this 12AX7 on the input. They each have their own cathode, 1.5K on the bias, but then different on the cap. That this is a 10 microfarad here on the base channel. 10 microfarads is going to let pretty much all of the low-end frequencies pass through, and so giving you, again, this is the first stage where these, or the first point in the circuit where these two signals differ. As opposed to a 1 microfarad here, that's going to just cut out a little bit of lows, trim some low end here on the input. Then on the base channel, 100K on the plate, also 100K on the plate of the treble channel, not any distinction there. That's the resistor that's going to help set the plate bias and the way that the tube is, like the load line is drawn to help the tube amplify and bias correctly. Then another point of distinction here on these capacitors. On the base channel, I'm running a 0.47 microfarad, which is a very large value, again, to let all those low-end frequencies pass through, whereas the treble channel has 0.001 microfarad. So a lot of bass frequencies are being trimmed out here. It's going to be a much more mid-range / treble focused. So really the heavy lifting here we've got so far are these caps, the cathode bypass caps, and then also these decoupling caps to help voice the channels differently. Then I go into a 500K audio taper bass volume pot. I'm calling it the bass pot, but it's really just a volume or a gain control for the bass channel. Then on the treble channel, also 500K, but this one have a little bit of a bright cap, 250 picofarads. But I also use a 220K resistor. That resistor is just to dull or to prevent the bright cap from being as strident as it maybe otherwise would be. Actually, my memory tells me I think I actually adjusted this down to 10K. But somewhere in the 10 to 20K range is going to be fine. And again, so basically these three caps here, the 1 microfarad, the 0.001, and this 250 picofarad, these three caps are making this signal path very bright and trimming a lot of bass, allowing a lot of treble to pass through. Then we run into the grids of these two second gain stages. These, I actually just put the cathodes together, 820 ohms on the bias resistor on the cathode. Because this is being split into two triodes, it effectively doubles it. So each triode sees like 1.6K, so pretty similar to the 1.5. And then just a 10 microfarad cathode bypass cap for kind of maximum gain. Because again, I'm wanting the output of this gain stage to join the signal back together. So I'm not using this cap to do any tone shaping because the triodes are going to join. Then do have a little bit of one final cap here, and I'm missing a resistor. This is actually incorrect. This pin 6 goes up to this node and has a 100K resistor, so this is actually drawn incorrectly, my bad. But on the bass channel, I've got a snubbing cap here, so the audio signal gets amplified through the plate. It comes out right here, and then this 0.001 microfarad cap can send some treble frequencies up basically into the power supply. And if you guys remember, wires can carry both AC and DC. This wire is carrying DC to power the plate, but the AC signal, it basically just gets lost in here. It kind of sees it as if it were ground. So those treble frequencies are basically sent to nowhere. And so another cap, so this cap, and this cap are making this side of the circuit here, the preamp, very bass driven. So again, you've got a dark bass channel, a bright treble channel. These volume controls help you balance between the two. Then we got a 0.02 microfarad decoupling cap just to prevent any DC. And 0.02 is a pretty modest, moderate, middle of the road value after all the tone shaping's been done here. We got a little cathode leak resistor here to just help stabilize this. And then I did also put a grid snubbing resistor here as well, just to keep this happy. A 5F1 Champ does not have this resistor, I believe, but I like to add it just to help prevent some blocking distortion to keep this output tube humming along nicely. Then last thing of note, I've got 620 ohms at 5 watts. So again, because my output transformer was pumping quite a higher voltage into the situation, I needed a higher ohm or rated resistor to bias this 6v6 properly, and then 10 microfarads decoupling cathode bypass cap to basically let most of all these frequencies pass through. And then for the tube itself, I'm running a JJ 6v6, which is a little bit of a beefier output tube compared to a vintage 6v6 because, again, of the higher plate voltage to make this thing run properly. So that is my circuit in an overview nutshell. Again, simple, inspired by a Champ, but with this kind of interesting parallel inputs where you can blend the two channels together to get the tone you're really looking for. So let's go ahead and dive into the build now. Okay, this is how the build has played out. Input jet signal comes in here, goes into the first gain stage, the 12AX7, goes into the components on the board. Now these first two gain stages are split into parallel, one bright channel, one dark channel. They come together. They each have their own volume control, then they mix together. I've got some shielded cable here in the middle to kind of keep things nice and tidy. Then we go from there into the output tube here, a 6v6. We're cathode biased. Got a little bit of power supply stuff over here with our B plus step down, filtering caps. Now I do have this braided black wire goes to a filter choke. And then I got a step down resistor right here. So just 3 B plus nodes. And then tube rectifier. The output transformer's up here in the corner. Try to keep it away from the input a little bit, but the output jack is right up here above. As far as grounding, it's actually a pretty simple ground plane. I literally, just this top row, every black wire you see on this top row is a ground that just jumpers one to the next, And then it all ties in at one single point right here on this green wire to this bolt to the power transformer. Now I do have a second, the yellow wire here from the middle of this IEC plug is grounded here on that lug, but other than that, the only other grounding I actually do have is the shielded cable. I just grounded it to the back of the pot. So other than that though, the grounds on this thing should be pretty simple, straightforward. It's all just basically like a single point star ground. So yeah, let's start doing some initial testing. I've got my light bulb current limiter here. I've got my range of tubes available. Now I've found a 5U4, couple 6V6s, a couple old 12AX7s. If I was really going to make this thing sing, I probably would get some new 12AX7s, and then probably the 5U4 might be okay. I think a 5Y3 would also be pretty good. I do want some voltage drop, but we're going to start with this and see how far it gets us. All right, I have a light bulb current limiter connected to 120 volts of alternating current in the wall. I got a power cord going into this IEC cable right here. Let's just see how we are doing, see if this thing's working. So first, I'm going to go across the hot and neutral wires. So I got 119 volts coming into the IEC. Let's go all the way over here to the other side of the switch. Okay, so my switch is working. If I flip the power, just know I have a tube rectifier in, but nothing else. Light bulb current limiter lights up. Our AC is now getting across the switch. It's going to be a little low because the current limiter is sucking some of that AC. That's why it's not quite at that 119, 120 volts. That's fine. Okay, let's see this one into the power transformer. We're going to go to pins 4 and 6 here on the tube rectifier. We got 230 volts of AC on the tube rectifier. Let's see if this tube rectifier is rectifying. We're going to switch to DC. Oh yeah, 473 volts DC. It's pretty high voltage. 473 volts of direct current. I got 500 volt filter caps. Let's test each of those legs. 474. 474 from the choke. 474 here. I don't have anything to draw current, so that's fine. Turn it off. Okay, I'm going to put a JJ6V6 in. I'm also going to get a speaker cabinet. I'm going to plug this into speaker output jack just to provide a load on the output transformer. Okay, the amp is on, a little flash, it dies down. Tube rectifier's got to warm up. Visually inspecting the tubes, that they are glowing. Let's see where we're at on this tube. Let's try the plate. Plate voltage is going up, 365, now coming back down. Why is that happening? Kind of settles in at 247, I guess. Let's check AC for the heaters. Our heaters are down at 2.1. Guessing that's the light bulb current limiter. I'm going to turn it off. We're going to try some 12AX7s. That's a good sign. Okay, I got the full complement of tubes. My volumes are way off. Let's put this on the 6V6 plate voltage. Amp is powered on. Little flash. Turning the volumes up. I hear a little hum. That's a good sign. Interesting, you can already hear with the hum. You guys probably can't hear it, but
The hum from the bright channel is much brighter, and the hum on the dark channel is much darker. It has like a different EQ to the hum. That's kind of funny. Probably a good sign. Okay. Let's take it off the light bulb. Alright, let's plug in a guitar. Let's go! Woo! It works! Alright, next order of business is to see how well this JJ66V6 is being biased. I go to Rob Robinette's Tube Bias Calculator website. I enter the plate to cathode voltage. Plate is pin 3. Cathode is pin 8. I got 375 volts DC. Calculate. We're looking at 14 watts. This is class, or it's cathode bias. 95% would be 35.5. Okay, I got a little problem. Information I put in here. Number of tubes sharing a cathode resistor is 1. The voltage across my cathode. Got my leads here on both sides of the cathode biasing resistor. So I've got 27 volts being dropped there with a 470 ohm resistor. That gives my plate current per tube at 54 milliamps, which is about 20 watts of plate dissipation. I want to be at 14. I want to be at like 35 or 37 milliamps of current, not 54. All right, the amp works. Actually sounds pretty killer. But I got to make a couple tweaks. I got to rebias it, and then the problem too is you can hear now it's really buzzy. If I turn the volumes off, it's quiet, but it's like both channels. So let's pop it open, see if we can do a little work, figure out why it's buzzing. Alright, well, I did some deductive reasoning, and the volume controls, when they were turned all the way off, the noise would go up and down with the volume control. So I figured it's got to be earlier in the signal than that. So I started looking, and this was my input jack, and frankly, this thing just looks really weird. Not really familiar with this. So I took it out, I replaced it with this. This is a stereo cliff jack style, and it's sleeveless, meaning the metal does not actually contact with the chassis. It's got a plastic sheeting, like a collar, so it's isolated. So the hot signal is here, and then this side is, like, if there's nothing plugged in, it's just muted. But then this other side is the ground, which I tied in over here. So if I plug a cable in, it's making noise. So let's actually plug a guitar in and see how we're actually doing. But now it's really quiet. Before we do that though, if I take the jack out, so now this input jack is grounded, if I turn these volumes up, it's very quiet. I mean, there's a tiny little buzz, but not much. So I do think it was maybe related to this input jack. Okay, I got my strap plugged in because I want to use a humbucker. The volumes are on pretty low, but if I just turn my... That sounds much better. So, yeah, I think the noise... That level of noise is so much better. So I think it was a weird, bad input jack.
All right, guys, there you have it. That is my 5-watt little custom build. Please let me know your thoughts down in the comment section below if you think this amp sounded good. Again, referring back to my design goals, I was trying to capture the touch sensitivity, responsiveness of a single-ended 5-watt champ, and I think it really nails that. This thing sounds really killer. Honestly, all I want to do is just plug a guitar straight in, use the volume control, use the tone control, use the pickup controls to get a wide coloration of sounds and just let this amp do its thing. And it sounds and feels really incredible doing so. It's really not super loud, but also like, I mean, when I crank this puppy up, I can probably hang with a drummer. And I'm going to be testing that here in the next couple weeks. So I'm excited to see how that goes. But it's a 5-watt amp, which is a nice little sweet spot for cranking these little tube amps up. but I wanted to marry that with a little bit of EQ flexibility. And I actually am really happy how this amp came in. The one channel is a little excessively dark, the other channel is a little excessively bright. But when you kind of blend or marry them together, it ends up kind of giving you a really nice amount of control, while also still retaining that purity and that, I guess, that tube tone and feel that you're going for. For example, I was particularly impressed because I was able to run both my Strat and my 335 style guitar. And in the past, with other amps, I found it's difficult to find a sweet spot with both of those. You know, the Strat is a little too bright, a little too strident, but then the 335, especially on the neck pickup, can get a little bit dark and woofy. Well, I was able to kind of favor, with the Strat, favor the dark channel just a little bit, maybe 10 or 20% more. And then with the 335, I ended up just cranking the bright channel and then bringing the dark channel back to about maybe 3/4. And that was a really nice mix where I was able to get that 335 to just bite a little more on the top end so it stays clear and articulate, and on the Strat to get a little more of that low end to pump it up from the bottom end. And so really being able to play both of these different extremes of guitars with this amplifier really accomplishes that goal for me. So really thrilled with how this thing came out. Again, it's dead simple. It's just two volumes, bright and dark. You use them together. Really happy it came out. It's extremely quiet. It sounds good. Honestly, I'm just pumped with how this thing came out. I think it would sound really good too with testing different tubes. It would show the character of the tubes. There's nowhere for them to hide, right? This is just the tone of these tubes shining through in a very pure way. So I'm going to stop gushing about it. Please let me know your thoughts in the comment section below. My next project really is going to be build a head enclosure for this thing because I am definitely thinking I got to try to gig this thing. Got to bring it out and play it. So I'm excited to do that. Love to hear your thoughts in the comment section below. Thank you for joining me on this journey. Please leave a comment, like, subscribe. We'll see you guys again soon. Thanks. Bye.